Hey, what's up guys, my name is Cherno, welcome back to my game engine series. So last time we took a look at GitHub pull requests and merged some of those in. Make sure that you check out that video if you haven't already. Today we're going to finally get to something that I've been wanting to do for a really long time, just for my own sanity really, and that is polling input, right? So we set up this whole event system, which is great because, you know, having an event system, receiving events whenever we press a key or move the mouse or like the window resizes, that's all fantastic, and that's going to form the basis for a lot of what we actually build in Hazel. But there is still the other side of input that is important, and that is polling input. So that's basically when instead of me being notified when something happens, it's me being able to at any point in our program ask, hey, is this key down? Is this mouse button down? You know, am I holding the Alt key as I move my mouse? Because if we do that, then something else we might want to change what that mouse move does based on if that's held down, right? For example, let's just say we're implementing a camera controller, right? And we want like a Maya style camera where we hold down Alt and then like, you know, the middle mouse button or the left mouse button to rotate, you know, and then we move the mouse. I want to check that the Alt key is down. I want to check if the left mouse button is down. And then if so, when I move the mouse, I might receive a mouse move event. And on that mouse move event, if the Alt and the left mouse button are down, then I want to rotate the camera, right? Stuff like that. We want to be able to actually ask Hazel if something is down. Now, obviously, this could all be implemented client-side. From this event system that we've built, it's very easy for us to simply be like, okay, well, fine. In my layer, every time I get a mouse pressed event, I'll just set the left mouse button to be pressed, and then the mouse released event, I'll set it to false, and that way I can check. Well, yes, you can, but obviously that's a bit of a hassle, having to do that for like everything and build your own system. Why build your own system to do that if that's something that Hazel can actually provide? So that's what we're going to do today. We're going to take a look at input. We're going to make a class called input and like Windows input, because this will probably be platform dependent, at least. I mean, the whole platform dependency thing is a little bit shady right now because we are using GLFW, which theoretically means that all desktop platforms will use GLFW, but I still, as I mentioned, and what I did with the Windows window class, right, I am splitting everything up per platform. The reason I'm doing that is because in the future we might want to move away from GLFW and we might want to use something else on Linux or Mac versus Windows, and so because of that, that'll be a huge refactor. I don't want to do that. I still want to keep all the platforms separate in case there's maybe something in those files that we end up making only for that platform. So that's the reason for that. Let's jump in. Let's implement this input class. Okay, so the first thing that I want to start off by doing is over here in Hazel. I'm going to come over into source. We'll explain platform in Hazel. And then just over here in Hazel, making sure that I've got show all files showing, so that I'm not like creating stuff in filters. I'm going to add a new item. We're going to call it input.h, and that's really all it's going to be. We're just going to have a header file that is our input. This is very similar to what we had for the window header file, where we just had a just this window header file, right? And then from there, it was just really an interface. And then from there, we had an implementation where we had Windows window. We're going to kind of follow that same convention here. We're going to implement everything inside Windows window, and then this will just kind of be just that, right? But there's a bit of a difference because with window, everything here, they're just methods. Whereas with input is going to be static in the sense that there's going to be one global input kind of manager, and that's it. Whereas you can have potentially several windows, several things like that. Input, I don't want to be, I don't want that to be per window or anything like that. It's going to be global. Now, technically speaking, you will probably have, the separate windows thing is interesting because, again, I didn't want to make window completely static. It is right now though, because if you look at application, an application is static. You have one application per Hazel, that obviously has a single window. So right now you can only have one window. So whether or not window is static doesn't matter at this point, but input for now at least will be static. There are many ways that we could deal with that, and there are kind of interesting complications to that, because on one hand, if you have multiple windows, then maybe you want to pull input from a particular window. On the other hand, if it's static, you could still do that. You could just say that if you ask the input class if the mouse button is pressed, it will do that for the currently active window, because obviously you can only have one window active at once anyway. You can't have two windows focused at the same time on your computer. So yeah, there's a lot of things to consider. I'm not gonna kind of spend too long kind of going through all of them because I don't think that's necessary. But anyway, we're just gonna begin with the input class and see where that takes us. So Hazel API input, I'm going to include, I don't even know what it's called anymore. I think it's called something else in my repository, but Hazel core.h to get that Hazel API thing. And then we're just gonna have essentially just a bunch of static functions. So is key pressed is kind of probably one of the most important ones. We're just going to take in a key code. Now, right now, this will end up being a GLFW key code just because we don't have key codes. We need to make our own key codes. I've been stressing that for a lot. We might do that next episode. But we need to have our own key codes because we can't tie ourselves to GLFW because, of course, that's going to end up being potentially different on other platforms, as well as obviously like that's not going to be a thing on like Android or other kind of devices once we kind of get into that space as well. Now here's the thing, this is static. However, what I'm going to do is I'm actually going to make this a singleton. So we're going to have a single instance of this input class like that. And then what we're going to end up doing is returning s instance and then probably the implementation of this function. Now this is where it gets interesting because whilst that is a thing, what we're actually going to end up doing is having protected virtual functions. So essentially this is key press. We're going to have a virtual version of that, which is not static. We're going to call it is key pressed impl, which stands for implementation. And then that's going to take in a key code, of course, and that's going to be pure virtual. So this is what we implement per platform in that actual like realization, I guess, of this interface, because this is just an interface. We do have like a variable, but it's static, so it doesn't actually belong to this class. This class has absolutely no data in it. This is just a static global kind of S instance. This does not belong to the class. So that's essentially how this whole thing is going to work. And then that's going to call that, and then there you go. Okay, so is key pressed calls the implementation, and then that obviously is something that will be kind of implemented by your interface. So just to kind of show you an example before I add everything else, in platform Windows, I'm going to make a new item. I'm going to make a header file that's going to be called Windows input.h, and then I'm also going to make a CPP file with the same name, so windows input.cpp. I'm going to include my precompiled header, of course. Every time you make new files, by the way, especially CPP files, you need to rerun premake because as this stands, I'm not sure whether or not this will actually be included in the precompiled headers. It may be. You can see it is set to use because that's the default for our project. So actually maybe you don't have to rerun it. I usually do anyway, just for sanity, but it's not something you have to do. So we'll include windows input.h, and then we're gonna obviously do stuff in here. I'm gonna copy this, whoops, and put it in here. We're going to include Hazel input, and this will be class Hazel API. Well, actually, I probably don't want to actually export this into the DLL file. So we'll probably just say, like I don't think we want it to be. I mean, we might, yeah, we probably won't have to. We'll see how this works though. So, and then this will kind of just override that. So protected, this will kind of just override our function. So our virtual bool is key pressed. Int key code. Okay, so that's the override from input. Sorry, this one obviously. And then we'll kind of just implement that. And then what this will actually do, right, is actually call GLFW, and then do everything that we need to kind of do there. So this will be tied to GLFW, which is totally fine because it's inside Windows. It's inside our platform specific CPP file. So it's not going to get compiled on anywhere where GLFW might not be available. what we're going to do is we're going to actually get the window from the application, and then we actually need to get the GLFW window. So this is interesting because we do have an implementation for this, I think, but it might need to be changed. Because here's the thing, right? At the moment, if you take a look at our window, this is quite interesting actually. I'm kind of glad that we're getting into this because it opens up a lot. So at the moment, we have no way to access this, right? We have a GLFW window, however, we can't access that at the moment. Now, there's several things we could do. We could make this public. That'd be probably the worst thing you could do. We could make Windows input a friend of Windows window. That would make sense because input window kind of tied together could do that. But because I want to kind of make this API somewhat powerful and potentially to people even in the client side who might want to, for some reason, do something that Hazel doesn't do, I actually want a function, a public function in the API which exposes GLFW window. Now, I obviously want this to be somewhat portable, and like I don't want this to be specific for Windows window or anything like that. I don't want to do too much of that. So what we're actually going to end up doing is inside window, we're actually going to add something here, which is essentially going to be a virtual void pointer get native window. Okay, and what this will do is and we'll make that const. What this will do is actually return our GLFW window. Now, the reason it's a void pointer is because, of course, this doesn't have to be a GLFW window. If we're using some other windowing library, like this could potentially return like an hwind or something like that. Could be anything, right? But in this case, it's returning just this native window, okay? Just this kind of GLFW pointer in this case. So we'll copy this. We'll go into Windows window. We'll paste this in. We can make it inline. And I'll probably keep it as virtual. This is another question I get quite often. Why do I keep virtual in here, right? So I don't do it everywhere. You can see I really don't. I do sometimes. I probably should do it more often. But for example, in here, I kept this as virtual. And people are like, well, hang on, is something going to like extend this Windows input class? Am I going to have a child of this class? And that's why I want this there? The answer is no, it doesn't matter. The thing is, when you make something virtual over here in the base class, everything down the hierarchy, like everywhere down the hierarchy, this function will be virtual. So if I don't put virtual here, it doesn't matter. It's still a virtual function. Why? Because it's obviously deriving from a virtual function. So this is meaningless. Like just because you don't put it there does not mean this is suddenly not virtual. Okay? So you might as well put it there because that's kind of a reminder of the fact that it is virtual. It's kind of like why we use override. Although override actually will generate compile errors if you like, you know, mistype something because you're not actually overriding anything, whereas virtual won't. But it's just a little reminder that this is in fact a virtual function. Again, you might not need to have that because you have override there, and that makes sense that obviously it's overriding a virtual function. But usually, like most people decide to actually leave this in here because it is in fact a virtual function. So why not have just that extra readability in your code to kind of just, you know, let you know that it is a virtual function. So that's why I do that, okay? Because it doesn't make a difference whether you have it or not. Okay, so so there's our get native window, and this is just going to return our M window, which is our GLFW window. Fantastic. Now that we've got that, back in Windows input, all we need to do to access our window, and by the way, the reason we need to access our window, maybe I should have started with that, is because we want to call GLFW get key, okay? That's going to tell us whether or not a key is actually down. So the first thing that we need to cast into here is actually, to pass into here is our window pointer, and then it's the key code. So key code, easy, but window pointer, something that we need to actually pass in. So that's what we're doing here. We're getting window, which is going to be equal to application. So we need to include Hazel/application. We're doing application get, and then get window, okay? This gives us back just a window reference. Once we have that window reference, we can get the GLFW window, right? By doing get native window. So this is going to be, we can just leave this as auto. So this actually, in this case, if we look at this, it's a void pointer. That's fantastic, but we actually need it to be a GLFW window pointer, right? So we'll just static cast it to that. Okay, so static cast GLFW window, and then that. So now this, of course, is a GLFW window pointer. Perfect. We can pass that in to window And there we go, our function is fine, okay? So this of course returns the state, whether it's kind of pressed or not. So we'll say auto state equals that. And then here we just need to return whether or not it's pressed. So return state equals glfw press, right? Or glfw, what is it, repeat, right? Like that. Oops, I don't know how I typed static. So there we go. So now what we're doing here is actually we're asking glfw if this key is pressed or if repeat or whatever, if it's held down basically, then we'll return true. Otherwise, if it's, you know, the other state, which would be release, then it's going to return false. So there we go. There we have that. Pretty easy, pretty simple. And now we have a way to also get the native window, which is really cool and really powerful. Okay, so if we go back to input, so hopefully this makes sense, right? We statically call input : is key pressed. We put in our key code, which right now is the glfw key code. So obviously we need to include glfw to use this, which is a little bit unfortunate, but that's just the way it is for now. And then from here, this calls the implementation of it, which is a virtual function, which in our case gets dispatched into this Windows input class, and calls this function, which of course actually asks glfw, and that's how we get our key. So hopefully all of that makes sense. Okay, cool. So that is kind of how that works. Now let's go back and actually we'll go into input.h and we'll do the rest of this, right? So the other things that we need to do for here is really just mouse stuff, and that's probably all we'll do for now. So we'll have a static, let's see. This can all be inline, by the way, because obviously it's implemented right here. But it'll be a static float, for example. We'll do I was going to do mouse position, but I'll do mouse button first. Is mouse button pressed? And then we'll do our int button. That will return, is mouse button pressed? Button. Hopefully you guys can see that, but if not, then that's what it returns, right? And we'll make that function in a minute. And then we'll do get mouse X, get mouse Y. And you can keep filling this out, obviously, but for now I think that's probably it. I don't think we need anything else. For now, that's all I can think of, really. Whoops. And we'll just actually do this and that and that. And these are floats. Okay, so now we have everything. We obviously need to implement this. So back into Windows input we go. I always confuse the two. Whoops. All right, so we can take this away and add override. I'll implement all of them just using Visual Assist. And then we can just implement all of them, really. So again, with mouse button, exactly the same thing. Instead of glfw get key, we do glfw get mouse button, window, and button. Now there's no such thing as the repeat state for mouse buttons, you know, so it's just going to be glfw press. And then for this, oops, I might as well paste this in. What we're actually going to use is glfw get cursor position, and then we need window, and then double x pos y pos as output parameters. All right, and then we need to pass these in by their memory address. So as pointers, and then we'll just return, in this case, S. Now this could be like, hey man, look, this is a waste of time, as in, you know, you're doing both, you're getting both here, whereas you're only returning the X position. And yeah, I agree, it's a bit annoying. We could return both, definitely, as a tuple or as something like that. In fact, we might do that just now, and I'll show you guys kind of how that works for fun. So this is the same, but Y position. So we'll go back to input. And we'll do a quick little get mouse position. I'll put it up here. Get mouse position. This will return a std pair of float and float. Get mouse position, cool. Let's copy this maybe, and we'll just do that. Okay, and then we'll obviously implement that inside Windows input. Just like that. This is mouse stuff. I'll create a function out of it, and then this will kind of do the same, but obviously over here it's just going to return the pair. So X position, Y position. And the really cool thing about this, by the way, is that obviously with kind of C++ 17, if you're using C++ 17, which I think we are, we can check quickly. Where is this language? Yep, C++ 17. What you can actually do, as I'll show you here really quickly, is if you get mouse position like this, which we might actually end up doing instead of doing all of this, you can actually do something like this, right? Auto XY equals get mouse position, and then we can just return X like that. Okay, the reason this works is because you can basically name these two floats that are being returned, which is really, really cool. And it definitely makes tuples and pairs a lot more convenient, because you basically can, name this whatever you want, instead of actually, having to do std get 0, this is my variable name, v, like that, to get like, because that's what it would have been like. That's what you have to do in C++ 14 or below, but in C++ 17, you can just do this, which is really cool. All right, so that is that, and we don't have to cast it to anything, and we'll do the same for here as well. So pretty cool stuff, glad we added that. That's basically it, right? We've done absolutely everything in our input class. The only thing that remains is actually creating this input thing, right? So we need to actually, somewhere in our code, we need to actually create this instance. And of course, since this actually has to be Windows, like the Windows instance, we have to create it inside Windows input. Well, we don't have to, but we're going to do it here. So input s instance is going to equal null pointer in this case, but we're going to just have it here. And sorry, this is a input pointer. So it equals null pointer here, and then we need to initialize our input at in some way or another, and that's what will actually set this up. So a good place to do this would probably be Windows window, and then all we really need to do is actually set it up here. So this init function would, for example, be a really good place to do that. However, again, because input is completely static, it's just data, right? It's just data and a collection of functions. It does no initialization. It's not like it has a constructor that relies on anything. So what we can actually do here is just set it equal to new Windows input right here in that static block. And that's it, right? Now we have this whole Windows input thing, which actually will statically initialize this. So if we want to see this in our code, maybe in application.h, or sorry, application.cpp, all we need to do to actually use this is I will include input.h, and then over here, maybe in the run loop or something like that, I'm just going to do hz core trace. We'll put this little thing in. Maybe we'll just do 0, 0, 1. And then we'll put in, I'll do auto XY as I did before, input, get mouse position, XY. Okay, let's run this, see what happens. Okay, so we should see over here that you can see we have Hazel and then the mouse position, right? It's also printing all the events, so it's a bit hard to see, but there you have Hazel and then the mouse position. Okay, there you go, being printed. So we can definitely see that that is in fact working. Anyway, I hope you guys enjoyed this video. If you did, you can hit that like button. Huge thank you to all the patrons on patreon.com/Cherno that helped make this video possible. It wouldn't be here without you. If If you want to support that, you guys get the next video early, so like you'll get it straight away basically as soon as you see this public on YouTube, as well as the Hazel development branch where I've already done all this stuff and way more. So you can kind of skip ahead and see Hazel as it's actually being developed by me in my spare time. Next time, we'll probably implement those key codes and mouse button codes that I talked about. Feel free to play around with this. I only tested get mouse position, but you guys should test get mouse X, Y, mouse buttons, and key buttons as well, and make sure all that's working. So that's a little bit of homework for you guys. If not, if I did something wrong, open a pull request on GitHub. Last video will teach you how to do that. And then I'll merge it in and I'll fix it. Hope you guys enjoyed this video. I'll see you next time. Goodbye.